Okay, so this is our second lecture, semester 2 for discrete probability distribution, module 1. So let us define what is cumulative distribution function. Okay, so definition: the cumulative distribution function, and we call it as CDF, and denoted by capital F of x, of a discrete random variable x, of a discrete random variable x with the Pm of p of x is defined for every number x, then cumulative distribution function f of capital F of x equal to p of capital X less than or equal to x. That means set of all value, probability of all values less than or equal to x. X takes the value less than or equal to small x. That is summation over y less than or equal to x, p of y. For any number x, f of x is probability that the observed value of x will be at most x. So that is what we call cumulative distribution function. That is f of x is simply probability of capital X takes the value small x less than or equal to small x. So we will add all probabilities. So we will take an example. So a story carries a flash drives with either 1 GB, 2 GB, 4 GB, 8 GB or 16 GB of memory. The accompanying table gives the distribution of y equal to amount of memory in a purchased drive. So y is the random variable, that amount of memory in a purchased drive. So the y can take the value 1, 2, 4, 8, 16 and their corresponding probabilities are given. So now we will determine cumulative distribution function. So first what will be f of 1? So f of 1 is p of y less than or equal to 1. So only value which is less than or equal to 1 is 1. So this is p of y equal to 1, p of y equal to 1, which is equal to p of 1, which is 0.05. Now f of 2 is p of y less than or equal to 2. So less than or equal to 2 means it will count 2 and 1. So that is equal to probability of y equal to 1 or 2. That is p of 1 plus p of 2, which is equal to 0.15. Why? Because p of 1 is 0.05 and p of 2 is 0.10. So if we add this, we will get 0.15. Now f of 4, next value, f of 4 is p of y less than or equal to 4. This is equal to p of 1 plus p of 2 plus p of 4, 0.150. And f of 8, we will add all this, p of 1, 2, 3, 4 and 8, and that is 0.90. So p of f of 16 is all sum of all probability, that is equal to 1. Now for any other value y, f of y will be equal value of f closest possible value of y to the left of y. For example, if we want to find f of 2.7, okay, so here f of 2.7 is not here. Why doesn't take the value? But we can, so by definition f of 2.7 is p of y less than or equal to 2.7. So the closest value left of 2.7 is, so left we have to take, this is 2.7, So left of 2.7, the closest value is 2. So y of p of y less than or equal to 2, which is equal to f of 2.15. Similarly, f of 7.9999. So if you take 7.7 is here, 4 is here, 7.999 is here, and 8 is here. So the closest value towards the left means this side. So it is 4. The closest value towards left is this 4, right? 7.99 is here. So left closest value is 4. And therefore we can write the probability cumulative distribution function 0 if p y less than 1. P of y less than 1 means there is no element, right? So this is 0. In between 1 and 2 it is 0.05, between 2 and 4 it is 0.515, etc. 1 when y greater than or equal to 16. So that is cumulative distribution function. So this is what about cumulative distribution function. Now next we will define a very important definition, that is expected value of x, or it is called mean of a random variable. So let x be a discrete random variable with a set of possible values t and pm of p of x. The expected value or mean value of x denoted by e of x or mu is e of x is equal to mu of x, which is equal to summation x into p of x. That means e of x is actually summation over x into p of x. So we will multiply x value into corresponding period. Okay. So we will go through an example. So just go through this example. Just after birth, each newborn child is rated on a scale, Apgar scale called. The possible ratings are 0, 1, etc. up to 10, with the child's rating determined by color, muscle tone, respiratory effort, heartbeat and reflex, irritability, and the best possible score is 10. Let x be the Apgar score of a randomly selected child born at a certain hospital during next year. Then suppose that pm of x is, so we have given the Apgar scores 1 to 10. So the newborn child will be in any of 0 to 10 Apgar scale. So their corresponding probability from previous studies is given this. Okay. Now we want to find out the expected or mean value of x. So mean value of x is e of x, and I told you that this is equal to mu, which is sigma over x into p of x. So first value is 0, and their corresponding probability is this 0 into 0.002 plus 1 into 0.001 plus 2 into 0.002, etc. plus 8 into 0.25, 9 into 0.12 and 10 into 0.01. So if you multiply and add all these, you will get 7.15. So therefore expectation or mean of a random variable is 7.15. So this is very easy. Okay, so that is all about mean. So here we define what is mean, and we go through an example. Now next we will define variance of a random variable. So first of all, let x be a random variable with pm of p of x and expected value mu. So e of x is mu. Then the variance of x denoted by v of x or sigma square, or denoted by sigma square, is variance of x. We know that this is sigma d belongs to x minus mu all square into p of x. The definition of this is the definition of variance of x. So this is equal to e of x minus mu all square, e of x minus mu all square. So that is so e of x minus mu all square. There is a and shortcut e of we know that e of ax plus by. If x and y are two random variables, then by expectation this is actually equal to e of x plus b times e of y. So this is a property of expectation of x. By definition we can easily. So now we will define a shortcut method. V of x is equal to sigma square is equal to, by definition we know that this, okay, so that is e of x minus mu all square. This is equal to e of x square minus 2x mu minus plus mu square. Now which implies this is equal to e of x square mu e of x plus e of mu square. So this is equal to e of x square minus 2 mu, e of x is mu square, plus expectation of a constant, mu square is always mu square. Okay, so this is equal to e of x square minus e of x all square. So that is the shortcut formula for variance. It's a example. So here it is given that PDF P of 3 equal to 0.15, P of 4 equal to 0.05, P of 5 and P of 6, and expectation of x is given. Okay. So variance of x equal to e of x square minus e of x all square. So here first we will find e of x square. So remember one thing, e of x square is x square into p of x. There is no square here. So 1 square into 0.30, 2 square into 0.25, etc. 6 square into 1 point. So e of x square minus e of x all square, which is equal to this. Okay. So this is your exercise question. So I will share this in your WhatsApp group. So you just do this problem. Okay. So